All right. Welcome to Introduction to Logic. I'm Nathan Wildman. Lovely to see you all. Yeah, I'm super happy to get to teach this again. I really love teaching this course. The first thing to say before we dive properly in, can everybody hear me okay like this? Is that okay? Cool. The first thing to say before diving in is I'm not going to go through any of the kind of course admin and practicality stuff. Hopefully everybody saw the kind of introductory video, the lecture 0 that does this. If not, no big deal. The link to the YouTube is on the Canvas page, etc., etc. Everything that is important for this course will be communicated to you via the Canvas page. You'll get announcement emails, things like this. So, what are we actually going to do if we're not going to be doing that sort of stuff? Well, we got 3 things to do today. I'm going to start by talking to you a little bit about what exactly logic is, very broadly. In particular, thinking about what I want to call formal logic. And we'll give you a little bit of a sales pitch as to why it's useful, why it's important, why you should be studying it. After we do that, we're going to talk about some background notions. So here I'm going to throw up some definitions for you, some various, we'll call them pre-formal logic concepts. And one of the things we're going to do, at least in the first half of the course, is give us more precise versions of these concepts. Maybe a better way to put it is, I'm going to give you some logical machinery that will help us track these pre-logical concepts. But I want to present them here. And then finally, we'll wrap up by talking a little bit about the building blocks, the first steps in truth functional logic. That's the first formal language we're going to learn. The big secret about this class is that it is somewhere between a language class, a mathematics class, and we'll call it a philosophy class, but that's just barely. So what this actually means is that most of the lectures are going to be me just spitting stuff at you, right? Telling you information, really just kind of showing you how the machinery works to try and familiarize you with it. The bulk of where we'll actually learn stuff, the things that actually really help you, will be done in the tutorials. Because what we're going to do in the tutorials is we'll work through problem sets, we'll practice using the machinery. Make sense? Cool. Okay. So let's keep going. Let's talk about what is logic and why study it. So first thing to say, what we're really interested, I'm a philosopher, right? I love arguments. But of course, when I say arguments, many times people think of something like this, right? Which is just a fight, which cool, I'm up for that too, right? But that's not the sense of argument I'm really interested in. I'm more interested in something like this, right? So this is my dog, Mira. She recently passed away, unfortunately, but I keep her and my other dogs in the slides as sort of memorial, right? So this is an argument. Mira's a dog. All dogs are canines. So Mira's a canine. Not a terribly deep argument, but this is the kind of thing that logicians are interested in, that we are going to be interested in. It's an argument. So maybe just to put a little more meat on the bones, we can think of an argument as a structured sequence of sentences. Doesn't matter what language. In this case, it's English, but it could be in Dutch or German or Nahuatl, or as we're going to see, a bunch of formal languages. And we can talk about the structure of this argument. So we have what we'll call premises. 1 and 2 are premises. They're the kind of things that are meant to give us reasons. Reasons for what? Well, reasons to buy the conclusion, to accept the conclusion. The last sentence in the string. This is going to be really wild and crazy, right? This is stuff you've been basically doing your whole life, maybe not necessarily thinking about it in this kind of way, but you're familiar with this kind of thing, right? Okay. So just to give us a definition, we'll say that an argument is any collection of premises together with a conclusion. So first fun question, what's the minimum number of premises we need for an argument? Interesting. Yeah. Cool. Can anyone go lower? Zero, right? Any collection. What's the smallest collection? The no collection, the empty collection, the number of friends I have, right? So an argument could even just be no sentences, a line, and a conclusion. That is a minimum version of an argument. Now, most of the time we'll deal with things that are a little more complicated than that, but this is already gesturing at something that, a kind of soft skill, I want you to think about in this course. One of the things I actually want to teach you. When we see things like this, when we get definitions, when you get rule sets, think about the edge cases. Think about how things kind of break when you push them to the extremes. That's very helpful if we're designing formal systems, if we're programming, if we're playing around with artificial intelligences, for example. Just a fun little tidbit to get us started. So, an argument, any collection of premises together with a conclusion. Philosophers, of which I am one, are argumentation machines. You feed in food, coffee, in my case, too much beer, and we output arguments. But of course, outputting arguments, much like many of the things that I output, sometimes are good and sometimes are pretty shitty, right? So let's ask, what makes an argument good? What separates the good from the bad? Well, here's a basic thought. A good argument is such that if you believe the premises, if you buy them, if you think they're true, then the good arguments will give you justification, rationale, for also thinking that the conclusion's true. So a good argument's one where you can somehow get to the conclusion or justify the conclusion from the premises. Super intuitive, super rough and ready, but we see the basic idea, yeah? So a good argument's going to be one where, hey, to go back, if 1 and 2 are true, well, they kind of give me a reason to buy the conclusion. Okay. So that's kind of a rough and ready characterization for a good argument. But what about a bad argument? Well, a bad argument could go bad at least in 2 different ways. One way we'll call the way of content. So this is when an argument's bad because one or more of the premises aren't true. We don't accept them. We don't believe them. The second way we'll call the way of form. This is where, right, it's not so necessarily about the truth of the premises, but it's that they don't really give us a reason to buy the conclusion. So let's unpack these 2. Let's start with the way of content, right? So here's an argument. There's a sense in which this is a bad argument. Again, we'll talk about Mira, right? So premise 1, Mira's a sausage. Premise 2, Mira's not cute. Premise 3, all non-cute sausages are felines. Conclusion, Mira's a feline. Right? Now note here that all 3 premises are bad. Mira's not a sausage, even though I might call her that, or might have called her that. Mira is obviously cute, and I will fight anyone who says otherwise, right? All non-cute sausages are felines. Not so sure about that. Right? And of course, the conclusion's false as well. Right? So this is a bad argument in the sense that the content here is poor. The premises are false. Yeah? But there is a sense in which this is actually a pretty good argument. And the way it's a pretty good argument is if 1, 2, and 3 were true. If they happen to in fact be true, even though they're not, if they were true, then they would give us a reason to think 4 is true. Does everybody see that? This is the kind of idea that we're going to try and capture with this way of form. And in fact, that's something we're going to be working on for the rest of the semester. So here's an idea to capture this way of form. We'll say that a conclusion follows from the premises whenever It's such that if all the premises are true, the conclusion must be as well. Or to put another way, the argument will be valid. We'll say an argument's valid if and only if it's impossible for all the premises to be true and the conclusion false. Now, a quick little thing. Know this definition. Know it, love it, write it in your heart. It will be the first question on the midterm and the first question on the final exam. Because this is the notion we are going to be tracking for the rest of the semester. So, an argument's valid. Whenever the premises are true, it guarantees the conclusion's true as well. Now, the important thing to note here about validity, it's not concerned with the actual truth or falsity of the premises and conclusion. It's a question of possibility. Is it possible to make the premises all true and the conclusion false? If it's possible, it's a bad argument, at least bad in the sense of form. But if it's not possible, if every time you flip the on switch for all the premises, the on switch for the conclusion is also flipped on, it's valid. There's no way to get these ones true and this one false. Okay, so before we move on, sorry.
Yeah. I do have a question though.
Please.
So is it possible to have all true premises but having a false conclusion?
Nice, we're going to come to that in a
Can I
second.
give an example?
Yeah.
So it's like Mira is not a sausage and I'm not a sausage as well. So am I Mira?
There you go. That's going to be true premises, false conclusion. So what do we think? True premises, false conclusion. Is that good in terms of form? No, it's invalid, right? It is not valid. Nice. Yeah.
When we're talking about an argument being valid, we're talking about just the form of it, right?
Yes.
And there was something in the book that mentioned a sound argument.
We're going to come to it in a second. It's about 4 slides away, I think.
Okay.
Good. So we feel okay so far. We got the definition of validity. Again, know it, love it, write it in your hearts. First question on the midterm, first question on the final exam. Everybody get it? Let's test it. Here's our argument we saw, right? I just went back a slide. What do we think? Is this argument valid or invalid? Remember, definition of validity. An argument's valid if and only if it's impossible for all the premises to be true and the conclusion false. Is it possible to make all the premises true and the conclusion false here? No, right? If 1, 2, and 3 were true, which they're not, but if they were true, 4 would have to be true as well. So this is a valid argument. This is already telling us something very useful. Again, actual truth and falsity is one thing, validity is another. Validity is not about the actual truth and falsity here. It is about a possibility. It's possible to make the premises true and the conclusion false. It's invalid. If it's impossible, then it's valid. Okay. So we had one. We talked about this one just a second ago, right? Again, this one, it's valid. If the premises were true, the conclusion must also be true as well. So next one. Yes, please.
So is this the kind of logic that is used in trials, for example? Is this the kind of logic that is used in trials, for example?
It's not quite. So we'll talk about the notion of reasoning that's typically used when we do prosecutions. We'll come to that in the second part. Good question. In the best of all possible worlds, this is the kind of reasoning we would use. But in order to do that, what you really need is to know the truth or falsity. Definitely know the truth or falsity of the various claims made by the prosecution and defense, rather than kind of making a guess at their truth or falsity. Yeah.
And how do we know, for instance, only a conclusion can be valid?
Good question. We're going to talk about that in the tutorial. But think about it. Think about if you come up with a case. whether that it's valid. It's a fun example. There was another hand over here. Yeah.
But like these arguments are like false. We are saying false, but like premises, false premise.
Good. So this, yeah.
Yeah. And false conclusion, but like validity is like
Yeah. Exactly, right? So we have, this is a useful point as well. When we talk about truth or falsity, we will only ever talk about the truth or falsity of sentences. Sentences can be true or false. Arguments are not the sort of thing that can be true or false. Arguments can be valid, that is, they satisfy this definition, or they can be invalid. Note, sentences alone cannot be valid or invalid. This is a property of arguments, not a property of sentences. Truth is a property of sentences, not of arguments. We might speak loosely, and in fact, we often do. We'll say something like, oh, that's a valid reason. What we really mean is you could construct a valid argument using this reason. Good question. Okay. So, got our first one. Let's take our second one. Premise 1, Tilburg's in the Netherlands. Premise 2, Nathan is human. Question. Conclusion, Willemsweg is based in Tilburg. Valid, invalid. Ooh, we had some invalids. We had one invalid. Let's hear from the invalids. Why is it invalid?
Well, it's invalid because it doesn't connect. Like the premises don't connect.
Good. So let's put it in terms of the definition, right? Exactly in terms of the definition. So why is it invalid in terms of the definition?
Because they didn't say it could also be based somewhere else, but it doesn't. Yeah, the premises don't say that they didn't say it should be based on.
Nice, nice. So to put another way, right? It's possible to make the premises true and the conclusion false, right? Tilburg could be here, I could be human, but Willemsweg say maybe ran out of money in the 70s and ceased to exist, so it ain't based in Tilburg, it ain't based anywhere anymore. Right? We see the kind of idea there. You can think of other cases too, right? Maybe more like in the US, right? Teams move around. So Willemsweg packed up in the 80s and moved to like, I don't know, Breda, just for the funsies. That would be really weird. Again, we can come up with a bunch of scenarios where the premises are true and the conclusion's false. But if we can come up with even one possible situation, the argument's invalid. Okay. Interestingly, here, note that this is a bit like the question you had earlier, in that we've got true premises and a true conclusion. Because Willemsweg is the local football team. So again, actual truth doesn't guarantee validity. Okay. Everybody feeling okay so far with it? You got it? Get kind of grips? Kind of grips? One more. This is a highlight for me every year. One last argument. Premise 1. Mars has exactly 2 moons, Deimos and Phobos. Premise 2. Mars has exactly 37 moons. Conclusion. Tilburg is in California. Valid? Invalid. Let's check the definition, right? Definition of validity. Definition of validity says an argument's valid if and only if it's impossible for all the premises to be true and the conclusion false.
Also, the premises are like fighting each other.
Nice.
So it cannot be valid.
Well, let's think. What's impossible here?
Mars has 2 moons and 37 moons. Same time.
So it's impossible for the premises to be true, right? It's impossible for all the premises to be true. If it's impossible for all the premises to be true, then it's also impossible for the premises to be true and for me to be standing here and giving this lecture. Right? because that would require 1 and 2 are true, and I'm doing this. But that also means that it's impossible for 1 and 2 to be true and for 3 to be false. Because there's no way to do the first half. No matter how hard I work, I can't flip 1 and 2 both on at the same time. So what I can't do is flip 1 and 2 on and then 3 off. Because I can't do the first part. You see it? It's sneaky. It's sneaky. But it leans exactly on the thing that you spotted, right? 1 and 2 are what we'll call contradictory. If 1's true, 2's false. If 2's true, 1's false. So this argument is valid. And it is valid because it is impossible to make all the premises true and the conclusion false. Remember my definition. Now, I want to point out, this is a very weird case, right? This is absolutely an edge case. This is not the kind of thing we're going to be dealing with on the regular. But it's helpful, again, to push definitions, to see what happens when we hit them with weird edge cases. Yeah.
I have really formed it in my mind, but if the first two premises are jointly inconsistent, and we cannot infer anything to the conclusion, how is that?
Nice. So here's an idea. Think about it in terms of convincing someone. If they already believe 1 and 2 are both true, they'll believe anything. Because they've already believed something that's impossible. Right? It's, you know, the old joke about if you buy that, then I've got a bridge to sell you. It's that.
Alright.
If you're silly enough to believe these two things together at the same time, you're silly enough to believe that.
So that makes the argument valid. Alright, okay.
We can think about it this way. To go back to our definition. I put it in terms of truth and falsity. But no, we definitely don't have to do this. We could put it in terms of on and off. I've talked a little bit about that. We can just put it in terms of positives and negatives. We can put it in terms of voltages, values, weights. Don't matter. We're just setting up a system. But we have a funny choice. What happens when we run into a case where our initial conditions can't be satisfied? Given the way we've set this definition up, any instance where our initial condition can't be satisfied, we get what we call a triviality. We're going to talk more about this as we go along. But you get something weird like this. System doesn't know what to do at the beginning, so it outputs garbage. And in this case, it outputs whatever you want. Note it doesn't matter what 3 is. I could have put 2 plus 2 equals 5 down here for 3. I could have put Tilburg's in the Netherlands. It doesn't matter. We can plug any sentence we want in there. This argument's going to be valid. Because the premises don't work together nice. So again, this is not going to be a regular argument we're going to run into, but it's a helpful one for us to play around with a little bit to start to see how the shape of validity works. So validity is a property of arguments, and an argument's valid if and only if it's impossible for all the premises to be true and the conclusion false. Yeah.
So, for example, in this example, let's say the conclusion was 2 plus 2 is 4, which is something that's true. Then would this become an invalid argument now?
Still valid. So here's the fun thing. If you're invalid because of this reason, you have premises that just don't work together nice, you never lose your belief. Okay. So, again, we're playing here, but this is our definition of validity. Now, of course, validity, as I said, isn't concerned with the actual truth or falsity of premises and conclusions. But you might think that we should be. Very plausible. So we can introduce another notion. This is a second, much less interesting notion, at least for our purposes here. And this is the concept of soundness. We'll say an argument is sound if and only if the argument's valid and all the premises are true. So an argument's sound if and only if it's valid and all premises are true. So there's some interesting things here we can ask about the conception of soundness. If we have a sound argument, what's the truth value of its conclusion? If we have a sound argument, doesn't matter what it says, but if we have a sound argument, what truth value does its conclusion have? Is it going to be true? Is it going to be false? Why is it going to be true? Yeah.
Because the premises are all they're all valid. So or they're all yeah, positive.
Yeah. Cool. So they're true. Yeah.
Yeah. So it yeah, so it's supposed to make sense, and that's why it's positive.
Yeah. Right. So, right, we're told the definition of soundness that the premises are all true. You got it, right? Premises are all true. And we're also told the argument's valid. Definition of validity tells us whenever the premises are true, conclusion must be true. Well, we know the premises are true, bang, bang, conclusion must be true as well. Now don't stress too much. Maybe play around with these during the break. Just think about these a little bit. Right?
When we say true when it comes to being sound, we talk about factual or not factual, right? That's
So again, in this case, what we have to be concerned with, if you're paying for soundness, is you got to find out, are the premises actually the case? Right? That's one reason why soundness is much less interesting to logicians. I'm interested in whether an argument works. And one of the things that we'll often be interested in is whether an argument works in cases where we don't know the truth or falsity of the premises. We're trying to, have a political argument where we don't know the actual, say, relevant ethical political facts. But we can say, hey, if these were all true, you still wouldn't be able to get to your conclusion. That's a valuable thing. Okay, so again, we've got validity, we've got soundness. Let's move on. Logic, at least formal logic, is concerned with validity. It is the science of valid reasoning. We're concerned with settling whether arguments are valid or invalid. There'll also be some other properties along the way, but really, they're just tools to help us do this. This is the big money. But why validity? Why not soundness? Well, we sort of had an answer just a second ago. Discovering that an argument's valid guarantees that at least it's got a good form. That is, if the premises are true, the conclusion must be as well. So that means it will be useful in situations where we're not able to tell the truth or falsity of the premises. We can still evaluate an argument in that context. Moreover, it puts us in a position to say, hey, the argument's valid, the structure's good, but now I need to go show why this premise is false and why that would actually matter. As I say in the slides, when we're thinking about validity, I'm thinking of logic in this way. Logic turns out to be useful for clarifying when arguments are good or bad, regardless of the truth or falsity of the premises. We can use it in situations of epistemic unclarity, where we don't know the truth or falsity of it. It's still going to help us reason. That's the real value. So that's the kind of implicit sales pitch. We're going to think about validity, and this is the reason. Because it's all about structures. It's all about structure. There's also some slightly more precise ways we can express this. Formal logic, the thing that we'll be doing, works by employing formal languages that strip away irrelevant material and they lay bare argument structure, argument or syntential structure. And a formal language, you guys know what a formal language is. If you've done any programming, you run into something that's pretty damn close, right? It's a language with a hyper-precise syntax, a semantics designed for use in situations where natural language isn't very helpful. What we're going to do here is we're going to learn 2 and sort of 3 formal languages. The first half, we're going to learn true functional logic. That's what we're going to spend the first 3 weeks on. And then we're going to spend the rest of the first half of the course learning FOL, first order logic. You might have also heard these as sentential or propositional logic and predicate logic. These are tools. They're formal languages designed to help us track things like validity. TFL in particular is an extremely powerful blunt force instrument. So that's what we're going to be trying to do over the next 7 weeks. And then we're going to build off of this in the second half. So why study logic? I mean, there's interesting philosophical stuff. I think it's intrinsically interesting, but whatever. Perhaps most important for you guys, it's just going to be the basic functionality. This stuff underpins so much of what you're going to be doing. So yeah, that's the sales pitch. That's what logic is. That's why you study it. I hope that's reasonably clear. Of course, there's a much flatter-footed answer for why you study it, because it's one of the classes you have to take. So, haha, you're stuck with me, fuckers. Right? Okay, before we move on, any questions about validity or about, yeah, please.
Is it technical to judge the validity of an argument based on form?
Yeah. So I think the important thing here is what we're really trying to do. You can think about an argument someone gives you, and you say, look, here, this is the way I think I understand the argument. It's got this sort of structure. Do you think this is the structure that you intended? If this is the structure you intended, these premises don't get you to the conclusion for this reason. It doesn't have to be an aggressive thing. It can often be a useful thing in elucidating someone's own internal reasoning process. So yeah, there's definitely useful and helpful ways to do it. There's also bad ways. But much like any tool, right, these systems can be put to bad use or good use. Yeah. Sorry. Either one.
Yeah, but I don't think that those systems really perfectly work on humans, because like humans are not like perfectly rational. I think we all have like emotions, or like humans are irrational.
I absolutely agree. But note, what we still want to do isn't necessarily think about human behavior. I'm interested in arguments that people give. Even if it turns out that what we can show is that the things you're doing aren't driven by arguments, it's still something helpful. One of the worst things we can have, generally, is somebody who presents themselves to be working perfectly rational, and that's all just a smokescreen. These kinds of things are going to help you at least figure that out. Now, what you do next is beyond my pay grade, but I hope that's helpful. Do you have a question? Go.
So if you have like true premises and then a true.
Good. So it doesn't mean that it's guaranteed to be invalid. We in fact saw one with true premises and true conclusions. Does anybody remember it? Very first one we saw. Right? This is a valid argument. And this is a valid argument with true premises and a true conclusion. So what's important here is that the truth or falsity of the premises and conclusion by themselves don't settle the matter about validity. It's always a question, to go to the definition, it's always a question about possibility. Is there a possible situation where the premises are true and the conclusion's false? If there's even one possible situation like that, argument's invalid. So the actual truth or falsity here isn't going to settle the matter. It's about possibility. Okay, good. How's everybody doing? I know you've already had one lecture and you got 2 more after this.
We mentioned that an argument can just be a conclusion with 0 premises. How can we judge the validity of such an argument? We'll come to it.
Let's get the machinery set up and then we'll talk about it. That'll be a fun case. Okay, so we're 35 minutes in. Everybody okay with 10 more minutes to go and then we'll take a break? Should also ask, normally with these kinds of lectures, I'm very happy with setting things up at the beginning where we ask, like, do people want to break or do they want to end early? I forgot to ask that at the beginning today. Would people prefer to have a break in the middle or would you rather we end about 10 minutes early?
Yeah, I mean together.
Everybody okay with, do we want to end early? Would that be better? Because then you'd actually have a little bit of a break before the next one in this exact same room. Everybody okay with that? So just pushing through and we'll aim to 10? Beautiful, beautiful. I should also stress, right? If you need to get up and go, like you gotta use the bathroom or whatever, you don't gotta ask, just go, right? It's fine, just trying to be able to reply. Yeah.
We said that an argument is any collection of premises together with a conclusion. And definition says, of validity says that the premise to be true. Well, we no scenario where the premises are true and the false. But we also said that any collection could be 0. So how does that work if we don't have any premises?
Good. So we can think about it this way. If it turns out that no premises are false, then trivially all premises are true. This is going to be something we'll get out because of a background assumption we're going to make in just a second. But that's going to be the reason why. In cases where we have no premises, then they can't be false. So they get true. At least in the sense of it's not possible for the premises to be on and the conclusion off, because there's no way to flip the premises on. Okay. So yeah, what we're going to do, we'll just push through, aim to end 10 minutes early or so, again, so you guys can have a proper lunch break before your next pair of lectures. Cool? Yes, please.
In an argument, you also have multiple conclusions.
So no. What you might have is an argument embedded inside a bigger one. So you might use a conclusion from one argument as a premise in the next one. That's no problem. Or you might chain reasoning, right? Use some premises to reach some additional premise, which then you'll keep going. This is something we're going to work on in the second half of the course. We'll do exactly these kinds of things.
Kind of an argument, sorry.
Yeah, that's okay.
With the same promises, have like different conclusions and both like right.
Sure. Remember that this one can have any conclusion you want. It's still valid.
Yeah, but
We'll come back, because there's going to be some cases. Okay, so let's talk about some background notions. First thing I want to do is some delineations to help set us up to talk about the formal languages we'll use. And the first thing is to delineate types of arguments. So this comes back to the earlier question about reasoning in like judicial cases. We can distinguish between 3 rough and ready types of arguments. The first type of argument, as we have here, we'll call a deductive argument. You have a list of premises, and you have a conclusion, and the premises somehow just entail the conclusion. The conclusion follows from, in the notion we used before, the premises. Contrast that with our second type of argument, an inductive argument. An inductive argument you'll be familiar with this kind of thing, right? An inductive argument has premises of the following type, right? Hey, I dropped the clicker yesterday and it fell down. I dropped the clicker the day before that and it fell down. I dropped the clicker the day before that, so on, as many days back as you want. Conclusion, if I drop the clicker now, it will fall to the ground. I'm not going to do it because it's not my clicker. So note, in an inductive argument, what you have is a sequence of observations, and the conclusion is then either a generalization or a future prediction. Nathan's come to class every day so far, so he's going to be here today. You see the idea? Generalization or future projection. This is the kind of thing that often happens in natural sciences. And the last type of argument we have is what we'll call an abductive argument. It's easy to get a run at this by thinking of an example. So, Bill and Ted had a fight last week, and they aren't speaking to each other. Right? But this morning, I saw them in their garage jamming out with each other. Conclusion, they must have made up at some point. So in these kinds of arguments, abductive arguments, the conclusion is an explanation for the truth of the premises. It says how it's possible that the premises are jointly true. Abductive arguments are also called inferences to the best explanation. Now it's notable, Sherlock Holmes famously says, oh, it's all deduction. That's bullshit. Holmes doesn't do deduction, he does abduction. He figures out the best explanation that fits with everything and says that's the conclusion. Which is fine. These are good ways to reason. But they're different ways to reason. Deductive arguments, again, these are the ones that we've been playing with so far. Inductive arguments, you have a generalization or a future projection. Abductive arguments, you postulate an explanation to account for your evidence. Okay. Now, the long and the short of it, we're not going to talk about abductive and inductive arguments. Those are for other courses. I'm interested in deductive arguments. I want guarantees. Because good inductive and abductive arguments aren't necessarily valid. The truth of those premises does not guarantee the truth of their conclusions. To go back a second, right? Our middle argument looks like a pretty good one, right? You've got reasonable evidence to think that if I let go of the clicker, it's going to fall. But of course, it's not valid. There's possible situations where I let go and it don't, because you have violations of the laws of nature, or whatever you want to postulate. So you can have good inductive arguments, but they don't reach validity. And remember, validity is a guarantee. If the premises are true, 100% necessarily, conclusion is true. And the same thing with the abductive argument, right? It might be such, in this case, that Bill and Ted are hate jamming. Right? Which, okay, cool. So, let's move quickly here. This isn't to say inductive or abductive arguments are bad, or useless, or worthless. They're just different. They're aimed at different things. It does mean, though, that valid deductive arguments have a level of epistemic security. The knowledge that they provide is secure in such a way that the other arguments can't really meet. And that's fine. That's absolutely fine. What we're going to be focusing on here are deductive arguments. We're going to see, hey, can we deliver this beautiful, epistemically perfect, secure systems? We'll do our best. Do our best. But when we think about things, to come back to the question earlier, like court scenarios, stuff like this, it's often going to be using these two. In fact, typically it's abduction. The best explanation, beyond a reasonable doubt, is that this person did it. That's the kind of thing. Not always, but typically. Okay. So we're going to be focusing on deductive arguments. Nice. We also need to say some things about the sentences we're going to be looking at to make up those arguments. The thing to note is we're going to have to use what we'll call assertoric sentences. You don't have to write this down. This is just helpful to know, right? Assertoric sentences can be contrasted with non-assertoric ones. Shock horror. Non-assertoric don't say anything. They don't assert. So here are some examples. Questions. Hey, can you get this round of drinks? That's asking the question. It's not asserting anything. Imperatives, commands. Buy the next round. Or exclamations. Oh my God. Again, not asserting anything, not obviously. Not making a claim about the state of the world. Contrast that with, you had too many drinks last night. That's making a claim. It might be true or it might be false. Note, there's not really a sense in which can you get the next round or would you get the next round would really be properly understood as true. Right? It's a question. It's not truth at. So, premises and conclusions, because we're interested in deductive arguments, are going to have to be assertoric. No questions, no imperatives, no exclamations. Makes sense. We need stuff that's apt for truth. Now, I talk about truth apt, and in order for these systems to work, we're going to make some simplifying assumptions about truth. In fact, we're going to make two. The first simplifying assumption is that we're going to say there's only two truth values. There's true, and there's false, and there ain't nothing in between. Things are definitely the case, they're definitely not the case, and that's it. Now note, this is a simplifying assumption because, hey, we got to start somewhere. We got to start walking before we start running. So we're going to assume there's true and there's false, and they're opposites, right? If you're true, you ain't false. If you're false, you ain't true. That's it. The other thing that we're going to have to do is we're going to assume that when it comes to at least assertoric sentences, truth and falsity are exhaustive. And what we mean by that is that every assertoric sentence is either true or false. Every assertoric sentence is true or false. It has a truth value. And no assertoric sentence is both true and false. Put another way, there's no truth value gaps. If you have a sentence, it has to have a truth value, either T or F. And no individual sentence is both T and F. Again, these are assumptions that we're going to run with to make our systems work. We'll come back to talking about these in the very last week of class. But the long and the short of it is, if we're dealing with premises or conclusions, every one of them's got to have a truth value. And none of them can have both. Cool? Okay. Now, running with this notion of truth, we can come back to something that we talked about with regards to arguments. Remember, when we're talking about the definition of validity, it's that an argument's valid if and only if it's impossible for all the premises to be true and the conclusion false. So let's think about that notion of impossibility and the associated notions of possibility and what we'll call necessity. Right? Necessity is something that must be the case. Well, when we think about sentences as groups, it seems pretty plausible that some sentences are such that it's impossible for them to be all true together. Right? Amanda is taller than Bart, and if we're not changing who the names pick out, Bart is taller than Amanda. We can't have both of these true at the same time. Mars has exactly 2 moons. Mars has exactly 37 moons. We can't have those true at the same time. So we can offer some definitions. We can say that some sentences are jointly consistent if and only if it's possible for them to be all true together. So you can flip the switch to on for all of the sentences. Or that some sentences are jointly inconsistent if and only if it's impossible for them to be all true together. Note that this is a property of collections of sentences. Could be 1, could be 2, could be 3, could be a billion. I'm obviously not going to ask you that many. But we can see how this might work. I can give you a collection of sentences, and you should be able to tell me, hey, are they jointly consistent, or are they jointly inconsistent? Okay. So far, so good? I should mention, and I think I forgot to say this earlier, one structural thing about the slides. So whenever we have a definition, I'm going to give it to you in one of these blue boxes, and the word that we're defining will be in all caps. So you can tab through the slides quickly and find the definitions again. So that means, to go back a couple things, I'm not going to ask you the definitions of acitoric and non-acitoric, for example. Right? That's just useful background for us to get out of the way. But I might ask you questions, in fact, I will ask you questions about these definitions, right? So, structural thing, help with the flag. Okay, so sentences are jointly consistent if and only if it's possible for them all to be true together. Sentences are jointly inconsistent if and only if it's not possible for them to be all true together. Please.
So consistency states like 2 sentences can be true separately, but they're only jointly consistent if they're true
Together.
It doesn't mean that both of them like singly are false or true. Only if they're consistent, they're true together.
Yes, yes. So here's a way to think about it, right? Take 1 and 2, right? 1 could be true, and 2 could be true. But the problem is we can't have 1 and 2 true at the same time. Right? It's not possible for them to be true all together. Okay. So, let's go to our next kind of collection of notions here. This is another one of my old dogs, Yopka. She's in here somewhere. Tattoo over there. We can think about Yopka for a minute to help us get a grip on 3 more notions. So I said that some sentences, when we think about their truth, look like they must be true. That is, they have to be true. Others might be true or might be false, and some look like they must be false. We can cash this out a little bit by thinking about some sentences. So take Yabka's on the grass, right? That could be true. It was in the picture. It could be false, as it is right now. So this sentence looks like there's a way to flip it on, there's a way to flip it off. How about either Yabka's fully on the grass or not fully on the grass? Well, if we think about this sentence, at least prima facie reading, it looks like no matter how the world works out, it's going to be true. Because, right, suppose Yabka's on the grass. Well, fully on the grass, right? She's no little back legs on the walkway or anything, right? Cool. Well, it's true because that first half of it's true. In any other situation, Yabka's not existing, Yabka's got a paw on the walkway, Yabka's hovering in the air, whatever, the other half's true. So no matter how things work out, at least one half of our or sentence is true. So no matter how things work out, it looks like our middle sentence is true. Again, don't worry too much about the particular example as long as you get the basic idea, the concept. And then finally, our third sentence, Yabka's fully on and not fully on the grass. She's in some sort of horrifying quantum entanglement state where she's just whirring furiously with legs akimbo everywhere. Right? No matter how hard we work, ain't no way to make this happen. So we have a sentence that could be true, could be false. Sentence that could be true, but is sort of stuck there. And a sentence that could be false and is stuck there. So let's give some definitions for these. We'll say a sentence is a necessary truth if and only if it's true and it's not possible for it to be false. Contrast, a sentence is a necessary falsehood if and only if, hey, shockingly, it's false and it can't possibly be true. And finally, we'll say a sentence is contingent if and only if it's possible for the sentence to be true and it's possible for it to be false. So to go back a slide for a second, and don't worry, I'll come back to the definition so you can keep writing them down, right? Our first sentence is contingent. Our second sentence is a necessary truth. And our third sentence is a necessary falsehood. You might think about them this way. Our first one is locked in the on position. Our second one is locked in the off position. And the third one's one where you can toggle the switch up and down. Now, there's something that should be worrying you, I hope. When we talk about possibility, how do we understand this notion? What sort of crap can we throw into our imaginative scenarios to play around here? How wild and crazy can it be? I mean, like that weird quantum entanglement, Yabka weird freak machine thing. Like, is that a possible situation? No. It's hard. It's hard to delineate the relevant notions of possibility. So one of the things we're going to do is we're going to develop machinery to help us specify what kinds of possible situations are even on the table. So we're going to characterize these notions again in terms of our two formal systems, because they're going to help us delineate what actually even is going to be like grammatically possible. Just a pin for later. We'll come back to it. Okay, so we've talked about joint consistency and inconsistency. We've talked about necessary truths, necessary falsehoods, and contingency. Most importantly, the sweet, sweet notion of validity. And soundness too, but whatever. I want to wrap up by talking about the first steps into our formal language, into truth functional logic. And as a reminder, truth functional logic is a formal language, a tool designed to help us track things like validity. It's also going to help us track things like joint consistency and inconsistency, necessary truths, falsehoods, and contingencies. But those are a kind of byproduct of the big thing. We want to get validity. And to get there, what we'll do is we're going to take some steps into what we're going to call formalization. So, let's start with an argument. Here's Yabka again doing what used to be her favorite thing, sleep. So, premise 1, Yabka's asleep. Premise 2, if Yabka's asleep, then she's snoring. Conclusion, Yabka's snoring. First question, valid, invalid? Valid, invalid? What do we think? What do we think? What do we think?
Valid.
It's valid, right? It's valid, right? If premises 1 and 2 are true, then it guarantees the conclusion is also true.
Can a premise contain a conclusion? Because premise number 2 has a premise in it and then a conclusion.
It doesn't have a premise in it, it has a sentence as part of it, right? Put another way, 2 is what we'll call a complex sentence. And it has simpler sentences as parts. That's totally fine. But remember, being premises or conclusions is about where you stand in the structure. Good question. Okay. So, our argument, valid. If 1 and 2 are true, 3 must be 2. Cool. Here's another argument. This is about another one of my old dogs, Vlekia. Vlekia was adorable. She used to sit, if you were sitting, she would get in your lap. She was so sweet. Okay, premise 1, Vlekia's awake. Premise 2, if Vlekia's awake, then she's happy. Conclusion, Vlekia's happy. Valid, invalid? Valid, right? Does it look familiar? Same damn thing. Both arguments are valid, and both have the same structure. Premise 1, blah blah. Premise 2, if blah blah, then blue blue. Conclusion, blue blue. You see it? Here's the cool thing. It doesn't matter what we slot in for blah blah and blue blue, as long as we are consistent. If it's the same sentence, and note it has to be a sentence, if it's the same sentence in every one of the blah blah spots, and the same sentence in every one of the blue blue spots, cool. Guaranteed to be valid, does not matter what the sentences are. Neat. Neat. So we might, blah blahs and blue blues are fun to say, but we might clarify it a little bit, and instead of replacing the phrases, or using the phrases, we'll plug in capital letters. We'll say A, if A then B, therefore B. Make sense? And you see what we're doing? We just replaced the sentences, the English, with capital letters. Cool. Welcome to the very first step of true functional logic. We are going to take away grammatically messy, noisy English sentences, and we're going to represent them using simple, pure, wonderful capital letters. Because all we're going to think about them as is truth value nodes. Are they on? Are they off? What do they mean? I don't care. I don't care what sentence A is. I just care, is it on or is it off? So each capital letter can represent any complete sentence you want, right? Yopka's asleep, Yopka's snoring, Blacky's awake, Blacky's happy, Nathan's fat, Nathan should lose weight. Right? No matter what we plug in, you get a valid number. Yeah?
In the third one, Nathan's fat, Nathan should lose weight. Does that be a counterfactual argument? What was something that should? Why was it counterfactual?
Good. But note that if the premises are still true, whenever the premises are true, the conclusion is going to be true too. So the structure here of premise 2 is going to guarantee that if 1 is true and 2 is true, conclusion's got to follow. Even if it is something about what I should do, rather than what I am doing. So good. Okay. So what we get, we can talk about argument structures. Argument structures can be represented using just these sentential letters. And we have something neat. We know that if we can map any natural language argument, any string of English sentences structured in the argument way, onto this scheme, we know the argument's valid. Don't matter what the English said, guaranteed to be valid. Now, of course, there might be questions about whether the premises are actually true, and whether the conclusion's true, and things like this. Hey, that's beyond my pay grade. I'm just trying to tell you whether the argument made sense. So this tells us a way forward. to assess the validity of natural language arguments, the kind that we hear every day, or that we make every day, or that we read in papers. We can map them into argument structures that we can then test to see, does the structure hold up? If the structure holds up, then we know at least that the argument is good in virtue of form. The premises support the conclusion. Yeah.
We talked about this with initially, but just to like make sure I understand. If this said A, if A then B, and then 3 was C, what's that?
Well, let's think. That's a good question. Let's think. If it said A, if A then B, C, what do we think? Valid? Invalid? Invalid. At least. Well, so we run. Why maybe?
Because of the fact of the meaning. The conclusion does not connect with the promise.
So it's an interesting thing here, right? If we had A, if A then B, and C, can anybody give me a case where we'll have a valid argument in that instance? Yeah.
If the A and but if the second and the first one are name, but like that's where they contradict each other.
Jointly inconsistent.
Yeah.
Nice. I like that. What's another way?
Conclusion has to be true. Like, how do you assess whether conclusion has to be true?
If the conclusion, so do we remember what's the definition? What's the definition of a sentence that's always true?
Contingent?
Necessary truth, right? Contingent when it's on or off. Could be both. Right? Necessary truth. So if C in this hypothetical case was a necessary truth, does it matter what the premises are? Why? Because it's impossible for the conclusion to be false, so it's impossible for the premises to be true and the conclusion false. Here's something very cool. Usually we talk about it in lecture 2. 2 ways to get validity on the cheap. Jointly inconsistent premises, necessarily true conclusion. We'll talk more about this as we go along. But again, just feeling it. So, spooling down, thinking about formalization. Our first steps into TFL. We've now got at least a pathway forward. We'll take natural language, English, Dutch, German, whatever. We will map it onto this sort of simplified expression to give us the argument's structure, the scheme that it's an instance of. We then see, is this a good scheme? Does it matter? Do the premises guarantee the conclusion? And if we can show that the scheme works, then we know that the natural language argument is at least good in terms of form. If the premises are true, then the conclusion must also be true as well. Which, of course, big if, but that's already a very valuable thing to learn. And it's worth noting there's plenty of other good argument structures. We'll talk more about these as we go, but I just thought I would flag them up. For example, we might have something like this. We have A or B. We know it's not A, so it must be B. I know he ran down the alleyway or up the fire escape. The fire escape's broke, so he couldn't have gone that way. He must have gone down the alley. If we know it's not both A and B, but we know that A is true, well, we know B is the one that's let us down. Alfred and Harry aren't both here. But here's Alf. Fucking Harry left me alone again, right? Or alone at least with Alf. And our third one, an interesting one. This is close to the structure we talked about before, but it's slightly different. If A, then B. Not B, therefore not A. If you did A, you're going to get B. You didn't get B, so what must you not have done? Couldn't have done A. Because if you do A, you get B. Again, we're going to talk more about these, so don't worry if it's going fast, right? We're going to work on these for a while. But the neat thing is if you can already see how we've mapped English to these, you start to see what we're going to be doing with these systems. Yes?
Why is A not true? Like, isn't it still possible A is true if B is not true in the first one?
Good. So let's think about it, right? If when we're testing the argument for validity, how would we do it? What are we looking for? Nice. Right. So to test it, what do we got to do? We make the premises true and see if there's any way that we could then make the conclusion false. So if we make 1 and 2 true, is there any way that 3 could be false? In this case, it would mean that A has to be true. But let's think about what happens if A is true. If A is true, given 1, B is true. But then, of course, we have B, and for premise 2, nothing. I have that. That's a contradiction. So it must be such that A isn't true. A must be false. You see the reasoning there? It was a little quick. But again, you can kind of think about it this way, right? If you go to the bar, then you're going to get drunk. Go to the bar, you're going to drink. You didn't drink. What must you not have done? You couldn't have gone to the bar. Because we granted, just for the sake of the argument, that if you go to the bar, you will drink. That's what 1 tells us. Make sense? Another example.
I'll think of it.
No, it's okay. It is tricky. Conditionals are weird, and we're going to talk about these in the tutorial. So if you've got more, don't worry if it seems really weird, because it is. It is. Yeah.
But can it also be like almost the opposite situation of if A then B and B is true, therefore A has to be true?
Nice. So that's not going to be the case. Right? To use another example, right? If you go to the bar, then you'll get drunk. You're drunk. Did that necessarily mean you went to the bar? No, right? I mean, not that I would ever suggest this, right? But you might have just stayed home. You see the idea. Again, we're going to play with these during the tutorial. So don't stress if it's not quite clicking yet, because all I'm really concerned with here, presenting you with the basic concepts we're going to refine, and the basic notions of this kind of formalization. So, to get going, so I just want to do like 5 more minutes maybe, not even. It's worth noting that there will be some arguments that are technically valid that we will not be able to capture using the method I just talked about. And that's because their validity is going to be hinged on the meaning of the sentences involved. Here's an example. The Pope is a bachelor. Therefore, the Pope is male. Now, this is a valid argument. And it's a valid argument because being a bachelor just is being an unmarried male. So if the Pope is a bachelor, he has to be male, just part of the package. But note, if we symbolize this into a structure, into a scheme, it would be premise 1, A. Conclusion, B. And that's very obviously not a valid structure. So we are going to miss some things with this approach. But that's okay. This is something we're going to come back to with FOL. But we're going to start by thinking about this notion just purely of form. Mapping natural language to this argumentation scheme. I'm going to give you a tool to then assess schemes. That's the plan. Okay, so the last step. Our first tool, our first formal language, truth, functional logic. We use it taking natural languages, map it into TFL, and we're going to use some beautiful, beautiful machinery for TFL. The fundamental building blocks of TFL are atomic sentences. Atomic sentences are sentences. So that means this language doesn't have parts of sentences. There are no words, there are no names, there are no verbs. TFL just starts with sentences. That's the smallest unit. But that's fine, because all that TFL uses to communicate is capital letters. In fact, secretly, this you were already doing TFL. So how does it work? Well, we take English sentences and we map them to particular capital letters. These capital letters can include subscripts if we need to have more than 26 of them. And these letters will symbolize the relevant English sentences. I want to stress, they are symbolizing the sentences. They are not a translation. And the reason why they're not a translation is that translations aim to preserve meaning. And there is no notion of meaning in TFL. Because all we have are just these letters. They're just truth nodes. So we do something like this. Nathan's hungry, capital H. Lincoln was shot, S. Either Yomka was awake or she's snoring. Well, let's have A be Yomka's awake and she's snoring. You see the idea. Yeah.
Shouldn't the third one be XOR?
What do you mean?
Like it's either one or the other, right?
Yeah, oh, cool. So we're going to talk about how to understand OR next week. But we only use inclusive OR. We're going to define exclusive OR. And at least in theory, she could be awake and snoring. You've got to see my wife. Yeah. Okay. But you see, again, the basic idea. We're going to need a guide. We will have a guide. It will be what we'll call a symbolization key. What's a symbolization key? It's literally just a table. Capital letters on one side, what English sentences they express on the other. Pretty easy. We feel okay with this beginnings of TFL? Nice. Some practice exercises. We'll skip them for this lecture because I think you could pretty much figure out how to do this mapping. If you worry, the slides are obviously on Canvas, so you can run through these. But just easy, right? If we got this, what's the first one going to be? A. All right, cool. We got it. Okay. The big advantage of doing this, the big advantage of moving to TFL like this, is we can ignore the noise. English is messy. English is very messy. Just think about how easy it is to misinterpret a sentence structurally. TFL is not. It's extremely clear. The big advantage, or the big disadvantage, is that we are going to lose a lot in the process. Implicatures, meaning, these sorts of things go away. But we're still going to have something. We're going to have, if the sentences are true or false, then we'll be able to track it and see. If we flip all the premises on, are we then forced to flip the conclusion on too?
In the process of finding the truth, isn't it important to understand the different meanings of concepts?
Absolutely. But we have to start somewhere. So what we do first is this. And this serves as our bedrock to then go into the more complicated first order logic, which lets us track meaning, which lets us do this disambiguation. So this is our brute force tool. This is our sledgehammer. Our fine-tooth comb and our fine tools, that's what we have to build to. But we start with this, because this is the bedrock. Okay, so what we're going to talk about next time, we're going to go into basically everything about TFL. I'm going to teach you TFL grammar. Yay! Who doesn't love grammar? So we're going to talk about how to connect atomic sentences using this thing we'll call connectives. And we're going to talk about the syntax, the rules for sentence structure, and I'll give you a definition for TFL. It's a massive slide. It's hideous. You're going to hate it. Right? So please, 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 read the next 15 or so pages of the textbook. More importantly, complete and self-mark these exercises. Notably, these are the things that we'll talk about in the tutorials later this week. So have a look at them if you want before the tutorial, but please come along. We'll talk about the tutorial structure, and we'll talk through these exercises. Go! Good luck with the rest of your day, guys.